Good morning children. Welcome back to Maths class. In our previous class we discussed about different types of angles and classification of triangles. Today let us discuss different type of quadrilateral. What is mean by quadrilateral? A closed figure made of 4 line segments are called quadrilateral. Here we can study 5 types of quadrilateral. Here you can see first quadrilateral, that is parallelogram. Parallelogram means it is a quadrilateral with the opposite sides are parallel and equal. Opposite sides means AB is parallel to CD. AB is parallel to CD and BC is parallel to AD. So this opposite sides are parallel and also equal. So we can say here AB parallel to CD and BC parallel to AD. Then second condition, AB equal to CD and BC equal to AD. That means opposite sides are parallel and equal. Then one more condition is there. Angle A equal to angle C. Opposite angles are equal. Here angle B is equal to angle D also. So total 3 conditions. Opposite sides are equal, then opposite angles are equal, then opposite sides are parallel also. Okay, then this quadrilateral is called parallelogram. Therefore ABCD is a parallelogram. This is our first quadrilateral. Next one, rectangle. Second quadrilateral is rectangle. Here also you can see opposite sides are parallel and equal. Then opposite angle also equal. So we can say this rectangle is a parallelogram. But in this rectangle you can see one more condition, that is all angles are 90 degree. Here all angles are not 90 degree. But in rectangle there is one more condition. Here all angles are equal and it must be 90 degree. So here we can see AB parallel to CD and BC parallel to AD. The same condition of parallelogram. Then AB is equal to CD and BC equal to AD. That also same. Here AB, that means angles. Next one angles. Angle A is equal to angle C and angle B is equal to angle D. Here already given all angles are equal. That also same condition from parallelogram. But one more condition, it must be 90 degree. Okay. So in rectangle there is one extra condition and that condition is not in parallelogram. So we can say all rectangles are parallelogram but parallelograms are not rectangle. Okay. All rectangles are parallelogram but parallelograms are not rectangle because it not satisfying one condition of rectangle, that is it is not all angles are not 90 degree, but in rectangle all angles are equal and it must be 90 degree. So here ABCD is a rectangle. Next one is square. Here this is a quadrilateral with the 4 sides and here you can see AB parallel to CD. Opposite sides are parallel, then all sides are equal. AB equal to BC equal to CD equal to DA. All sides are equal. Then angle A equal to angle B which is equal to angle C, then which is equal to angle D. All the angles are equal and also it is equal to 90 degree. So we can say this square is satisfying all the condition of rectangle. So we can say a square is a rectangle with all sides are equal. A square is a rectangle in which all sides are equal. Here only one extra condition, that is all sides are equal. But in rectangle opposite sides only equal. Here one extra condition, that is all sides are equal. Okay. So we can say square is a rectangle in which all sides are equal. Next one, rhombus. Rhombus also a quadrilateral and here you can see opposite sides are parallel and all sides are equal. Opposite sides are parallel and all sides are equal. Then opposite angles also equal. Opposite angles, not all angles, opposite angles are equal. Then we can say ABCD is a rhombus. What is the difference between this square and rhombus? In square, here all angles are equal and it is 90 degree. But in rhombus, all angles are not equal, only opposite angles are equal. That is the difference between square and rhombus. But there is all sides are equal in square and rhombus. What is the difference between parallelogram and rhombus? In parallelogram, opposite sides only equal. But in rhombus, all sides are equal. Okay, so we can say rhombus is a parallelogram in which all sides are equal. Okay, next, fifth and last quadrilateral is trapezium. Here you can see ABCD is a quadrilateral, and here only one condition, AB is parallel to CD. That means any one opposite sides are parallel, then we can say that quadrilateral is a trapezium. Here AB parallel to CD, then ABCD is a trapezium. Okay, let us discuss three-dimensional shapes or 3D shapes. Three-dimensional shapes or figures has three dimensions, that are length, width and height. Then the examples are, you can see in this figure. First one, sphere, then prism, cuboid, cube, cylinder, pyramid and cone. These are the examples of 3D shapes. Okay, next let us discuss some important points related with 3D shape. Here you can see one example of 3D shape, that is cuboid. Next, let us discuss the faces, edges and vertices of this cuboid. First, let us discuss faces of cuboid. Here, this surface is called face of cuboid. So, we can count total how many faces are there in this cuboid. Okay, here the first face, that is 1, 2, 3, 4, 5, 6. Here 1, then opposite side 2, then 3, opposite side that is 4, then up 5, down 6. So total 6 faces are there in this cuboid. Okay, so here we can write 6. Next we are going to discuss edges. Edges means two faces are joined, then we will get one edge. If two faces are joined, we will get one edge. So this is one edge, then second, third, fourth. So in one face there are 4 edges. In one face there are 4 edges. Okay, so we can count total how many edges are there in this cuboid. Okay, here if you are taking this as up portion, you can see 4 edges. 1, 2, 3, 4. Then down also 1, 2, 3, 4. 4 plus 4, 8. Then side 9, 10, 11, 12. So total how many edges are there in this cuboid? 12 edges. So we can write here 12. Okay. 4 in up, 4 in down. So total 8. Then 9, 10, 11, 12. These are the edges. Next we are discussing about vertices. Vertices means, one vertex means if 3 edges joined, then we will get one corner, one point, one edge. Okay, then sorry, one vertex. Then it is called vertices of this cuboid. So total how many vertices you can see here? 1, 2, 3, 4, 5, 6, 7, 8. 4 in up and 4 in down. So 1, 2, 3, 4, 5, 6, 7, 8. Total 8 vertices are there in cuboid. So face, then edge, then vertex. Okay, these are the faces, edges and the vertices of cuboid. Next let us discuss with the cylinder. This is one example of cylinder. And the cylinder, how many faces are there? You can see here one face, one surface, round surface. Okay, this is one surface, then up on another surface and down also. So total how many surfaces are there? 1, 2, 3. Total 3 surfaces are there in this cylinder. That means 3 faces. Okay. 3 faces are there in this cylinder. Then how many edges are there? Here one face and another face joined. We will get here one edge. Okay. One edge and a second edge. So total 2 edges are there in this cylinder. 2 edges. Then vertices. Can you see any vertex here? Any corner point is here? No. There is no vertices in this cylinder. So we can write here 0. Okay. So 3 faces, 2 edges and 0 vertices. Next one is sphere. Here you can see one example of a sphere. And in the sphere also we want to find out the faces, edges and vertices. Okay. How many faces are there? Here only one face, one round face. Okay. So we can write only one face. Can you see any edges? Any edges are there? No, there is no edges. Then there is no vertices also. So we can write vertices also 0. So in one sphere, only one face, no edges and no vertices. Okay. So these are the main things related with 3-dimensional shape. So only this much for today. I hope you understood today's portion. Study well. Thank you.